Hello, everyone. Welcome, and thank you so much for joining us today for the Dear Grower, Let's Design Your Greenhouse webinar. My name is Janine Wright. I am the Senior Communication Specialist at Prospian, and I'll be your moderator for this session. We're excited to have you with us today, and before we dive in, I want to mention that this webinar is part of our Dear Grower webinar series. We've already hosted one webinar in this series, Dear Grower, Let's Build a Greenhouse. And we plan to be doing more in the future to kind of walk you through all the different steps and what you need to know to work with your suppliers and contractors to bring your greenhouse to life. So you can find that previous webinar on our YouTube channel or on Bright Talk, and keep an eye out for emails that'll have more details for our next webinar, which is Dear Grower, Let's Make This Greenhouse Happen. That'll be held on October 22nd at 2 p.m. Eastern Time. For today's session, we'll hold all the audience questions until the last 10 or 15 minutes, but feel free to enter your questions into the chat at any time, and we'll get to as many as we can at the end. So now I'm excited to introduce today's presenters. We have with us Keith Vermer, Inside Sales Coordinator for Prospian, Rob Eggert, Director of Design, and AP Helterbrand, Design Manager for Prospian. So they'll be taking us through today's topics, and I'll let them tell you a little bit more about themselves. So with that, Keith, I'll hand things over to you.
Thanks, Janine. I appreciate it. Welcome, everybody, to our second series, as Janine mentioned. In our first series, we had one of our customers, Elmer Grosser from Diefenbacher Greenhouses, join us to get his insights on how to create a greenhouse, what he wants in a greenhouse, options that he would choose as a grower in a greenhouse, and insights to his facilities and in the future what he would do. In this webinar, our second part series, we're going to start talking to our designers. So after we receive a signed contract, what does it take to get into, get this greenhouse rolling? It's not as simple as just going to a bin and pulling out a bunch of parts. It actually takes a lot of design work ahead of that before that can even start to happen. So today I got two esteemed colleagues with me, Rob Eggert and AP, as Janine mentioned. Thanks, guys, for joining me today. I appreciate this very much. If you don't mind, could you give the audience a little bit of background and what you guys do here at Prospian?
Sure. I'm a registered architect. Started with Rao Brothers, now Prospian, 15 years ago. Before I joined Prospian, I was sticks and bricks architect. Worked on retail, restaurant design. High speed, high risk dollar wise for restaurants. So it was a very, very stressful field. Moving to the greenhouse industry has been probably the best career move that I've ever made. I really enjoy working with the growers, the end users, and it's been a great process.
Yeah, and for myself, AP Hildebrand, I've been around the industry pretty much my whole life. My father was in the industry. He worked for National Greenhouse since the 60s. I worked for National starting in '94 as a designer. As a contractor, came to work for RBI and now Prospian in 2014, and have worked my way through commercial design and commercial design management to various different roles.
Awesome. Well, thanks, guys. So let's get this a little started off. So a lot of people don't know what actually goes into a design of a greenhouse. After the customer signs off on a contract and sends it in, a lot of our customers just they know that it takes some time, to get through manufacturing and then actually get on site. But the first step is design. So if you don't mind, what actually happens the minute you guys see a signed contract? What do you guys do as designers when that gets handed off from a salesman like myself? What do you guys do with that contract? What do you get started with, and what's the process of getting a greenhouse designed and into the system?
I mean, the first thing we'll do is we'll take a look at the contract that you did, the work that you did. We'll meet with the salesperson, download whatever we can, that they learned from the grower or end users. But then oftentimes we will want to meet with the grower again and get more details about how exactly they're going to use it, or what size carts they use, what size shovels they're using for certain areas. And the depth we go depends a lot on whether or not it's going to be used for an institutional setting, a research setting, whether it's a wholesale grower. And, that's kind of the first step to assessing the scope. And then the next big thing that we do is look at schedule to see when they're either getting plants in, how quickly we need to get posts to site or get the ground covered. So schedule is a big part of how we plan what the rest of that's going to look like. And we want to identify any potential pitfalls early in the process.
Yeah. And once we've done that, we start through the engineering process. Your greenhouse isn't necessarily one size fits all. We have, codes and things to consider. So we size the greenhouse according to whatever local code or whatever recommendation we're going to have to meet to make sure your greenhouse is a solid structure. And then we begin the drafting process and have begun to also consider materials, demands, early requirements. We take a look at what your greenhouse is going to require for manufacturing and try to get that into the system so that we can meet a tight timeline.
So that's a good point, AP. I mean, you got a good breakdown on how I think we'll break down this webinar today. So let's start off with a little bit about knowing what your customer wants and talking to your sales team. So one of the things that was highlighted last month is that Elmer was really pushing like hanging baskets and hanging basket systems, and we got into a big discussion about trusses and truss cords and sizing and the whole 9 yards. And so that's one thing I try to emphasize, especially with a customer, is that, we need to know what you're going to do with this greenhouse, because the last thing we want to do is put a hanging basket in there and then you get McDonald's arches, or something that it falls, or we get a snowstorm and it's done. We gotta size those trusses accordingly. So with the codes and regs and, knowing that, customer may want a specific crop to grow in there, like hanging baskets, what things do you have to go through with, say, engineering or codes that would determine that truss, the gauge thicknesses, stuff like that?
You start with the jurisdiction that has precedence or oversight on the project. Find out what version of code. So building codes can be building structural energy codes can be very complicated. There are a lot of versions and a lot of types. Each jurisdiction is going to have what they prescribe to. So you may go to somewhere and they use the 2015 IBC, International Building Code, which is not very international. It's just the name of it. Or they may be on board with the 2018 IBC or the 2021. And there are nuanced differences between each of those, which is, part of what we're here to do, right? Is dissect that code and figure out. The big factors are wind, snow, seismic, and then now we get our fun energy codes are starting to have an impact on our industry. And
so can we break that down a little bit so that people understand? I think, just if you don't mind touching on like the wind, the snow, the seismic, what that actually means, and what does it mean for a greenhouse structure?
I mean, sure. Snow is obviously going to impact our gravity loads.
Yeah.
It's going to impact the size of your truss, your top cord, your bottom cord, and especially when we start adding 10 gallons per pound or 10 pounds per gallon of soil and water for each hanging basket, that goes on the bottom cord, or heavy fire sprinklers, on the bottom cord. So those all impact your gravity loads. The wind loads, typically, it's not just trying to push your building over. Wind also tries to lift your building up. So your columns end up increasing. The amount of sway rods you need in your greenhouse will drastically increase. Sway rods are, the X braces we see in the walls. I don't know if we can see any in our photos behind us here. However,
bring us right here. Let's see if we can find some.
Yeah, let's move around, pull up some drawings. You may end up needing knee braces that connect. That would be a brace that connects your column up to your truss. there's a lot of things that can be affected. And as you mentioned, I think gauge of the material.
Gauge and even base spacing in places like Alaska or heavy snow loads.
Yes.
But unfortunately, in the modern era, we are constricted by very tight codes and occupancy, how you're using the building, what the space is going to be. Some jurisdictions are a little bit more flexible on the use of the building, whether or not you're just growing, or if you have a protected facility, is it zone agriculture, is it commercial? That also adds a layer of complexity to how we have to treat the structure.
That's correct.
So basically, what you say is like loading is all the forces pushing against or pushing down on or lifting up on a structure.
And we have to resist all those forces.
Yeah.
And to an end user, a 2-inch by 4-inch bottom cord on your truss looks like a 2-inch by 4-inch bottom cord on your truss.
Yeah.
But whether it's a 10 gauge or a 15 gauge, there's a drastic cost difference between those.
Yeah.
And we do try to maintain a standard diameter of tubing, a standard size of member, but we do fluctuate in the thickness of the material.
Is there an actual like average wind and snow load across the country, or is there
No, not anymore.
Wind is actually extremely local. They have there's wind maps that we have to abide by, and then when you really dig into it, each locality may have more in-depth wind information. Snow is a little bit easier. There generally are kind of belts of where the snow loads increase or decrease. The worst is when you have high snow loads and high wind loads.
Right.
Just imagine a little straw structure and you put something heavy on it and then you blow on it. The thing wants to fall over real fast. That's the bad combination.
And one of the things that you guys did bring up a little bit earlier too was you're talking about permit process, and that's very important because obviously, as AP mentioned, occupancy is huge in certain greenhouses, especially in garden centers, schools, stuff like that. When I talk to a customer a lot of times across the states, I see a lot of times they say, "Oh, I'm in the boonies. I don't have to worry about that." And that's not the case anymore. We're seeing a lot where the biggest thing that I always tell customers is make sure you go check with your municipality. It might be your state, your local, or, even down to your township government, what they determined it has to happen for this greenhouse. And, a lot of them will require an occupancy permit. And that requires essentially a stamp drawing from an engineer and, or an architect for that matter too. And so, it's interesting because a lot of people are like, oh, it doesn't bother me. But, I've heard cases where someone has bought a greenhouse, didn't worry about it. The fire department shows up the day after the inauguration and says, where's your permit? And they don't have anything. And guess what? They're going to bulldoze it down, and stuff like that. So on that process, what are some things that, customers coming into it for the designers to know they should know from their local municipality or, within permitting or anything like that, that's important, or things that you see that are common that some people forget or things that, it's obvious on every single build?
Well, I mean, the zoning of the property is really one of the step one biggest things. Like I kind of prefaced with, the building codes and structural codes are a complicated maze of legalese. It's very difficult to even understand what they're asking sometimes or what they're telling you to do unless you've had experience or gone through it. That one of the big things, I just call it a general level of due diligence. Call your planning department, make sure that you're zoned properly, find out if you have an ag exemption. Call the building department and let them know, hey, I'm planning on putting a greenhouse in this location. You're not, giving away the cards or opening a can of worms, because like you said, if you get to the point where you're starting to build or you were actually at point of opening, and that's when the building department finds out that you have a project there, that's big dollars, big delays, and potential real headache. They're not going to be very kind with you. So doing some due diligence, making a few phone calls, or if it's a small enough locality, drive down to the building department and meet them for coffee and chat with them. They do great with building departments really enjoy some upfront notice that something's
Yeah.
going to come. They really,
Yeah, that's
And for the customer themselves, I mean, we've seen projects that unfortunately customers have had to walk away from because the zoning changed from what they anticipated originally, and that adds layers of cost and
Yeah, that's
so
that's very important because I had a project last year where we did contact the building department during the phase where we were coming up with a contract for the customer, and just to make sure that we were covered because a lot of things changed in the 20 years that they built their last greenhouses. And what we ended up finding out is the municipality really didn't know what the definition of a greenhouse was. They were so used to commercial buildings, and they were so used to the definition of residential, they were totally offbeat of what they knew on greenhouses. And luckily, somebody else in the area had recently built under the predecessor of the building department and had documentation for us that showed that the state says that you don't need any permitting for the site based off of the agricultural exemption. And it blew the building department away. They had no idea. But it's that kind of thing that took us 4 weeks to prove, and stuff like that, which really delayed the project. So yeah,
starting out with gathering as much information as you can coming in the project really does pay off, and there are instances where we do end up in situations where we do get in-depth inquiries from a building department. There's they're mostly consistent, but every once in a while we'll run into an anomalous, encounter. So
yeah.
Unfortunately, it's something we have to be prepared for, and the best case scenario is to have as many ducks in your row as possible.
that's
Yeah, I mean, some wild cards to be aware of when the greenhouse is attached to a building or occupies the public. There can be limitations of the amount of plastic you can use for a wall or a roof, which could dictate what your covering is. But that might fly in the face of your energy code requirements for that specific site.
Yes.
You could, and this is a real example, we won't share the exact project, but you run into funny stuff like this is right at the edge of I think, wildlife conservatory district. So it needs special material and sprinklering accommodations made. And lots of times when you have to sprinkle a greenhouse, you have to sprinkle above and below the shade system or between shade systems. It can become, very expensive. And then depending on what temperature you're going to maintain your greenhouse at, you may need high temp nozzles in the sprinkle system. And I'm talking about the fire suppression system, not our irrigation systems. We had one in California where the sprinkler main was very heavy. It was a big 8-inch sprinkler main. Well, the seismic forces that applied to the bottom cord of the truss, as the building's moving back and forth, that heavy pipe would put horizontal loads on the trusses, and it actually affected the size of our structure. So it can end up being a fun road.
Yeah, and to your point, somebody that built 20 years ago, I remember a time when 1/8-inch tempered glass was the gold standard. You didn't have to worry about it. Now, if you have a public occupancy, you can't put that overhead. There's just so many things that they're changing, and as industry expands, and what was once kind of a very specialized industry becomes more general to the public, it gets more application from the same rules that apply to everyone else.
And you guys touched on a great subject that I think we need to get into next, and that is the energy codes. We're seeing a lot, especially the state of California, that's changing theirs. So basically what we're talking about is trying to reduce the amount of energy it takes to heat said structure, and also retain heat within the structure itself. And California requires dual layer glazing systems. And so there's a couple ones you can check mark off right away. That would be double inflated poly, check. 8mm polycarbonate or acrylic, check. But tempered glass, like, the ultimate roof is not. You would actually have to put two pieces of glass on top of each other to actually meet that energy code. And a couple of growers in California were actually trying to go back and say, well, if I got a shade curtain system underneath that tempered glass, wouldn't that count? And the state said no, because when that curtain's open, you're back to a single layer. So energy codes, they're coming, more and more prevalent in bigger structures and stuff like that. And it depends on what each state adopts. So if you don't mind, let's touch a little bit more on energy codes or anything that you see that, everybody should be aware of, that, it's coming around the corner, I guess you could say.
Yeah, you hit on something there with adoption. That's one of the cards in our favor right now. Energy codes are slow to adopt because it can, although I'm a believer that we can be more energy efficient. It does slow down the rollout of these greenhouses and other businesses and other buildings, and just general development of a city, right, or a town or an area. So they are fairly slow to adopt these energy codes. But what we will say is, I believe it's the 2021 version of the IECC starts to change the definition of a greenhouse, or it doesn't change the definition of a greenhouse, but in the prior versions of that code, it would give an exemption for a greenhouse, and it was just stated greenhouse exemption.
Yeah.
Now it recognizes greenhouses as a type of structure, but it gives you a resistance level, an insulation resistance level, an R value, or the inverse, you might see U value of wall and roof materials that you need to maintain. Some strategies for that are using double wall and twin wall products where they meet the code. You'd have to look, each acrylic, poly, glass manufacturer is going to have published data on what their resistance and U values are, their R and U values. And, one of the methods that we would obviously endorse, and it's disappointing to hear the experience in California, but is using energy curtains as a method below, or, below a certain temperature or below a certain sun level that we'd have to seal to maintain energy, heat within the greenhouse.
Yeah. And it's a safe statement, given the combined years of experience here, that when we start to see small pockets of new approaches or new perspectives, new inquiries on how we code, how we build, how we apply to the municipalities' interpretation of code, it will spread. And what we're seeing in California will probably creep to other states and other municipalities, and before you know it, it's going to be widespread. So if you are a grower and you're thinking about your future, I would give that some consideration.
Yeah, and the changes are happening at a more rapid pace than they have in the past.
Yeah, most definitely.
You guys here, I'm a little youngin' in the industry at 15 years, right? Well, it's still in the 15 years that I've been here, I've seen an uptick in our structure size based on evolution of code and demand of code. And, when we talk about structure size and the energy code, they are directly related with each other. Because if I now have to support insulated glass,
Exactly.
that's twice as heavy as non-insulated glass, and sometimes even more, because you may need a laminated layer, then an airspace, then another laminated layer. Or a single layer airspace laminated layer. So it can become very heavy. And remember the whole thing about loads, and that affects our structure size. So now energy codes are affecting the cost of not just our glazing material, but the entire structure.
Yeah.
So we just need to be aware and plan, and lean on our industry partners to also make advancements in the U and R values of their glazing materials as well.
Yeah. And it's amazing. I mean, you walk through any greenhouse now. I mean, if, since we've been around for, over 80 years and stuff like that, if you walk through I call it the evolution of a greenhouse structure, you can walk through the same exact structure, but you will see major differences in that structure, namely in the gutter posts and in the trusses and stuff like that have evolved so much. For us, I mean, when we did a poly arch years ago, 25, 30 years ago, it was 2.5 inch square for a post. and then it kind of evolved to a 2x4, and now we're up to a 4-inch square. And that's just the evolvement of the structure. But it also makes it tough when you have to go backwards. If something happens, and stuff like that, something dramatically happens to the greenhouse. How do you repair a greenhouse, or how do you connect to it? If somebody wants to add on to the gutter, because you might be going from a 2-inch post to a 4-inch post, and you'll have to, have a specialized truss to be able to attach to it, because it's not going to just mate evenly, to match your width of your house.
Certainly.
So that's really important, to understand. And that really gets into our topic is engineering. So, we're talking about the evolution of 2.5-inch all the way up to 4-inch posts. Explain to people exactly what the engineering involves. Once something comes in, and there might be heat loads or seismic loads and stuff like that. What do engineers do on a greenhouse structure? What exactly do they need to figure out, and how does that help, or aid you in drafting or drawing the greenhouse?
Mystery to all of us.
Yeah. Yeah. Those guys are the wizards of the industry.
Yeah. Do it, Rob.
When we get a contract, we formalize a process where we request that the engineer do an investigation into local code, and they have to do their diligence in determining what factors, wind, snow, all those things that we previously talked about, and factor those into a calculation set so that we can size the house accordingly. They are an interactive member of the design process as things develop. As much as we try, there are gaps. But ultimately, your engineer, even if you have an ag occupancy, we still have to size the greenhouse so that it doesn't fall under its own weight, right? So even if we're not getting it permitted, we still have to go through the process of sizing your greenhouse for where it's going to be. Engineers take all the considerations that we have discussed and adapt that burden, and then they direct to the design team how to size the house, what your spacing on purlins will be, what the size of the truss members will be, the columns, even girts. And then the design team does the work of putting that into a design and laying your house out according to the plan that you want.
Yeah, and sometimes during that process where AP was saying they're involved in the entire design process, even after they come to us and they give us these initial loads, member sizes, that sort of thing. A member of the design team may be looking at the condition of a corner and say, you know what, we could actually get away with something different here. Let me check with our engineer and see if that will also meet it. Maybe instead of a 4x4, we'd be better off with a 2x4. Can the 2x4 suffice for this little spot, this occasion? We have other times where, let's not forget, it was only 3-4 years ago where we had major supply chain issues. We'd get a call from our purchasing department saying, hey, we can't get this material for 3 months. Can you use this material?
Yeah.
So the engineers are constantly playing feedback with the designer as to, how we can actually pull off the project based on their assessment. And we skipped a couple, two quick things with engineering.
Go for it.
Height and width are big factors.
Absolutely. Yeah.
Huge factors in the structure. If you want a very tall greenhouse, you're increasing your wind load. The wind speed's the same, but the more square footage area you have, the more load that is being applied to that wall. So tall greenhouses tend to have heavier structures, and of course, large spans, width of truss can really impact the size of your members.
Yeah, if you consider just how heavy you have to make the structure itself to support its own weight, right? We would love to design 100 feet wide clear span greenhouses, but that's very difficult to do.
Yeah, they have to support themselves too.
Yeah. It's 42 foot and even all the way up to 60 foot sometimes that we do. That's a wide span without having a post in the center between.
That's a big space.
Yeah.
Big space. Yeah. It's crazy. So, The other thing is it's coming up that we're seeing prevalent, and this is a lot of things that a lot of people don't know. Another behind the scenes thing is that we're seeing a lot of push from European manufacturers, Venlos, different other structures that are coming over from Holland and stuff like that. And we essentially designed the substructure for those roof systems. What does it take? I mean, we're seeing, a lot of growers pushing towards, these European style roofs, as we call them. What does it take to actually do that? Because I think a lot of people think that when they get a Venlo, it's coming from the States, but technically it's not, because there is no U.S. based manufacturer of Venlos. What does it take for you guys on a design team to mate our substructure to that customer's or that vendor's roof structure? I mean, obviously we're dealing SAE versus metric is one of the big things. How does that all play into how you guys designed it?
I have to be careful about my words here. Not that look, not disparaging anyone's product. The European manufacturers, they are great at what they do, and we've worked with them in the past very successfully. But there are several hurdles that we face when we do that. Getting back to member sizing, if we are supporting the structure for their glazing, which is typically the scenario, we speak with their engineering team and they will give us their size according to the European standards. And then our engineers are tasked with finding the SAE equivalents and then more or less verifying that size will work to the standard that our engineer has to meet, right? So the code isn't even the same. There's a lot of back and forth in that process and a lot of vetting and verifying when working with a European manufacturer.
And it's tough too, because European manufacturers change their designs almost every 3 or 4 years sometimes.
Right, they're leading in technology on a lot of these systems.
Yeah.
Right? The development. A lot of public funds go into the development of those systems, which is great. I mean, we're moving forward, right? But that is a point that does add some complications. So just a quick step back, when we have multiple glazing systems here at Prospient that we use, right? Depending on if we're going to be using 8 millimeter, 16 millimeter, 1/8 inch, 1/4 inch, those sorts of things. So depending on what the customer wants, the energy codes demand, the project, best suits the project, we end up with a glazing system. We have to then integrate that glazing system into our structure. With our own homegrown glazing systems, we know how many inches away from a gutter we need a hole for the glazing bar.
Right.
We know how many inches away from the peak of the truss we need to support our ridge, all those things. When we look at a European manufacturer, we have some basis of design from the ones that we use more regularly or our customers use more regularly. So we may have some inclination of where those holes need to be, but it requires the full verification each time because of exactly what you say. There are things that are changing, and we need to confirm that it hasn't changed since the last project we did with them. So it actually involves a little bit more coordination and time and effort to sister the European glazing system that isn't native to us, right? Because we don't know every detail of it. Not only are they changing their glazing systems or improving them, they have, just like we have multiple, they have multiple. So it may be their open roof system versus their Venlo system, or some sort of higher energy. I think they have a metal. Some of them have metal panel systems for insulated metal panels. These all can require slightly different connection points and braces and that sort of thing.
Yeah, I mean, it's interesting, Chris. I mean, even on a Venlo, and this is my warning for everybody out there, because I'm seeing this a lot lately. A lot of people, they want the Venlo. They think it's the creme de la creme and stuff like that, and they'll build these, and with that'll come repair bars. And lately, I've been seeing a lot of people throwing their repair bars away, and they go to the baseball field that's right next to the greenhouse. The ball goes smacking through your tempered glass thing, and you need to repair it. and the first thing you go is, where's my repair bars? And you're stuck because they have to come from Holland. There's no US based distributor. So it's important, on that case too, is, make sure you keep your Venlo repair bars, because it's getting tougher to get some of these ones and stuff like that. But so moving forward, we've talked about codes and regs. We've talked about some aspects of engineering. We've talked about loading and things like that. You've got all that in place. Take us through what happens now. Like when does it get into a draftsman's hands? What process now to get this greenhouse on paper? What steps do you guys have to go through now that you've got all that information to build out the drawings, to build out a material list, to get it ready for production?
Yeah, sure. I mean, not to get too technical about it, exactly what the designer does, but we have templates and toolkits and starting points, right? We're not starting with a blank sheet of paper or a dry erase board every time. We have some basis of design that we know if it's a steel structure with this glazing system that we need to space the posts at this level. So a design manager will get with their design team and kind of do the handoff, say, here's our engineering information, here's our member sizing, here's our schedule, we need the drawings by this time. And they'll do an initial, what I'll call either a schematic design level or a design development level, which are drawings that are not quite permit ready, but they're ready for the customer to look at and say, is this what you're looking for? Yeah, I heard what you said. I read the contract, but did we interpret everything correctly? And we also then need to give those drawings oftentimes to a mechanical, electrical, plumbing engineer, maybe to an architect, maybe to a foundation engineer.
Vendors that we work with.
Vendors, yeah. That's right. A European glazing system. They need to, and for that one, for that vendor, you need to start very early. There's little nuance things when you think just the different cultures in countries.
Yeah,
holiday and vacation schedules are wildly different.
Time difference and
and
a lot of people, what they don't know, they don't realize is time on the water.
Time on the water, yeah, and then time that we can actually talk to them each day. We only get a 3-hour, 4-hour window to communicate with them each day, unless we're going to wake up early, which we will do for you. Wake up early and hop on the phone a little earlier. But back to what, the designer's preparing these drawings, right? And they're going to different vendors. We're starting to get the feedback of control systems and, but it's kind of preliminary at that phase, right? We can still make changes if we find out that actually the loading dock's going to be on the other side, or, and that's the time to change. You don't want to change after you've gotten a permit if it's a permitted project. You don't want to change when you have a bulldozer on site. You want to change then. And so we ask the owners to look at it and users to look at it and give us the old John Hancock, that says, this is what we want.
Yeah, and simultaneously, while all of that is going on, we are sizing at manufacturing, right? So back to what happened 3-4 years ago, those ripple effects have still not changed, and I don't expect them to. We could slide into an extrusion order or materials order in a number of short weeks. Now we're looking at months for some materials. So as soon as we know that we're going to have a material demand, we're sizing the structure up early. We're making preparations for manufacturing so that when we finish the design process, manufacturing is ready to begin that. And unfortunately, that has affected our ability to deliver quickly. But it's modern world. That's just one of those things that we've had to learn to work with.
And one of the funniest things I think that I've, talking to you guys on a daily basis and over the 10 years I've been with the company and stuff like that, I think every single year, at least 20 different times, every designer always complains about doors. Yeah, I think what I'm trying to say here is that from a customer standpoint, customer love. I need a door here. I need a door here. I want this style door. I want to do this kind of door. But it is actually one of the most difficult things to design into a greenhouse is a door. And I've heard that of AP and U of I have had this conversation multiple times. Rob, and I have had a conversation recently about doors and stuff like that. It's a pain to get in and out of a greenhouse through the door, but it's truthfully, it's one of the most difficult things to actually design in a greenhouse.
Well, I mean, there's lots of considerations. Say you want a coil overhead door, right? That's a heavy door that you have to support in the structure, right? It's not just an opening in the glazing. There's ADA considerations in certain buildings. Going back to occupancy code. Sometimes customer just has a preference on what type of door they want in the structure, and it's not something that we would normally carry. So there has to be a communication process to go back and forth and figure out, what size of an opening, how do we accommodate that door to make sure that it fits seamlessly into our structure. So yes, doors are an unfortunate pain, but also a necessity.
And I think the larger pain is the hardware.
Oh yeah.
Once you get to hardware specing
yeah.
on doors,
Oh my
talk
gosh,
about a
yeah.
foreign language.
Yeah.
It is. It's even if you deal with it daily, but in one application you might just need a simple pass-through lock set with a handle, a few $100, or all of a sudden you need panic bar hardware that's tied into an alarm system. For it's upwards of thousands at that point because you need electricians involved and everything else. So
right.
Doors are they're a wild card for sure.
Yeah.
Sounds funny, right?
Yeah, you would think it would be, I'm just going to put a door here, but it's actually got a lot to it. I mean, it's a lot more difficult than actually designing a vent itself. Like a sidewall vent or a ridge vent or something like that, or even a shade system. You think shade systems are going to be one of the toughest because it's got more moving parts. It's down to the door. It's always the door's fault. So
I don't know. We probably got some shade systems that compete with those doors pretty well.
Yeah. It depends. It depends on a few factors, but I mean, in the commercial world, we're fairly standardized as far as our shade approach goes, and we're fortunate enough to have wide enough spans where we can standardize. But in the institutional world, we get some pretty uncommon width structures and sizes and pitches. And sometimes what we traditionally do just doesn't work in those spaces, and we have to get really creative.
Yeah.
I was going to say a step we skipped at the beginning when AP mentioned width there, if it's wide enough to handle a shade. Sometimes, most growers and users come to us knowing what it is they want and what it is they need to succeed on their project. But there are times we have to coach folks about zone sizes, like if it's a research facility. Sometimes we'll be working with, someone from capital investments at a university as opposed to the actual researcher or grower. And they'll come to us and say, well, based on budget, we want 200 square foot, we want 15 200 square foot zones. And we have to coach it like, no, you actually, that's probably not going to serve you well. And, we try to guide them towards the right. So sometimes we have some of that, in the design rule too.
Yeah, I mean, Shades, our in-house HVAC department, we have to design around what they have to do, because it's not like a house and you're in your basement and you can just drill a hole through a stud for a 4-inch pipe or, a 1/2-inch water line. You can't cut through steel to go through it. You got to go around it somehow. And so it's a big difference, but it all comes into play at the design. That team has to talk to your guys' team and go, make it happen.
Trades coordination is becoming has become a major concern and contingency that we have to account for, especially in the institutional world. You get your mechanical, your plumbing, everybody has a space in that greenhouse, and we as the manufacturers and designers have to account for the space in that house to be able to fulfill our contract and make sure that everybody else is able to do what they need to do in that space. And sometimes that is a very hairy process.
Yeah. So I want to, for our last couple of minutes that we've got, I want to kind of continue this because we had a little bit of, a lot of people commented how much they liked this on the first series with Elmer. the first series I asked Elmer, I said, if you had an unlimited amount of money and you had an acre size of a greenhouse, what would you build and why? And Elmer came, he would definitely do like a Venlo style and shade systems and hanging basket systems and stuff like that. So I'm going to kind of ask you guys, because, we're going to think outside the box here, what would, in an ideal world, what is one of your favorite greenhouses that we have in Prospient that you like to design? And what are some aspects that you really enjoy putting into that greenhouse? So, is there a specific type of cord of a truss? Do you like to powder coat them? It's free range. So if you don't mind, share with everybody, like what's your thoughts? What's your favorites? Because, we don't really ever get to ask the designers what they like, right? It's what they were told to do, but let's turn the tables. What would you guys do?
Okay, so you asked almost two questions. What would we do, or what was our favorite? I'm going to latch on to what was our favorite. So aside from being a designer and design manager and director of design, I also did project management as one of my stops here at the company. And there's a small garden. It was a privately owned property, and it was gonna get sold or taken over by a big industrial situation, and some people gathered together and got some money, and they opened a place called Udeld Gardens, Yewdell. It's near Louisville, Kentucky, and this was going to be their first greenhouse that they built, and they really wanted to incorporate a lot of energy efficient design elements. So although this created a lot of complication in what it is, in the actual design and implementation of the greenhouse, it was a painted greenhouse, so it had with like a hunter green, so it had a really nice setting in the botanic gardens. It kind of nestled into the earth, and on the north roof, it had a planted roof instead of glazing. They used the in-slab heat as it was geothermal, so you couldn't get a whole lot of heat out of it, just enough to kind of knock the ice off. But then they also reversed it in the summer to help cool the slab and cool the greenhouse a little bit. And it was just a really thoughtful design overall experience. The users were great to work with, so that one sticks in my head. I've enjoyed. If there's any other previous customers on here, I've definitely enjoyed all your greenhouses. But that one really gave me the warm and fuzzies, to be honest.
For me, I would say while I've been here at Prospient, Crusty Creeks was probably my favorite design. It afforded me some opportunities to get a bit creative. It had hips, valleys, and some things that we don't normally get to wade into. And it was a really beautiful house, and as I understand it, is will become a beautiful business and staple there. But from a design standard, if I had unlimited money and an acre, I would take a standard structure, and I would use the opportunity to explore, transparent glass with solar capability. All of the things that are just starting to kind of creep into our world in terms of possibilities with glazing and energy and radiant heat before things that we don't normally do. I would like to take a space and incorporate all of those things and really figure out how to make them all work. So that would be my dream project.
Good old R&D house.
Yeah.
Oh, R&D is wonderful. It's nice because I don't know if people can see our backgrounds and stuff. Like APU designed this greenhouse years ago. That was a good one. I think Rob, you did the one behind you guys too.
I worked on it, but we had many folks worked on this one.
Yeah. There's a lot of
it's White Oak, right?
That is White Oak. Yeah. White Oak is a garden center that's actually about 5 minutes from where I live. It was a gorgeous structure. They love it. It's a flagship garden center. And to this day, it's hustle and bustle. This picture here was taken. I took this picture with a drone about a year ago. It's kind of funny because we're getting into pumpkins again, the pumpkins in the background and stuff like that. But this is a glass open roof, which is one of my favorites. I love the open roof. I like the veil. the Vale is a great structure for a standard structure. It's great. I mean, the one behind you guys is every time I'm in the office and I see that on the wall, it's one of those wow factors. You still look at it and go, wow, even though, it's been years ago since it was done,
You
that's
can't even tell, but like all the glazing bars actually, or the sills in the header of the door and all the vents, they're actually skewed and they sit at an angle. They're not even sitting level. And then of course the little overhangs you have up there. These things were there were so many things to consider, and I know we're essentially out of time and moving to questions here pretty soon. But one big step we didn't have time to even really get into today is after we're done drawing the pretty drawings, we then have to go in and create a item by item list of every screw, nut, bolt, flashing, truss member, weld, etc., to submit to our manufacturing floor to actually fabricate it. We also have to include drawings
to make all those parts.
because if your truss is 3 inches wider than the previous guy's truss, well, that means the member's slightly longer, the struts in between are slightly longer. Whether you have a shade system or not may need holes. Whether you're using European or good old Prospian glazing systems, there's that takes as much, if not more, time than just drawing the elevations, plans, etc.
yes. And this is where it gets
That's a
into
huge
our
piece.
next part,
Yeah,
is where you start having to discuss this with the project managers. And
right.
this is where you got to explain everything you've done to them so that when the builder's out in the field, they know exactly where all those pieces, parts, and stuff go to the assembly, because the last thing you need is the wrong size bolt put in the wrong, the wrong member of the cord of a truss or something like that. And that's going to be the third part of our series next month is talking to PMs and what they see coming from you guys doing the designs and the material lists and getting it out of manufacturing to actually let's make this happen. Let's get this greenhouse going. Let's get it up. And so, yeah, that's a very important aspect of your guys' day-to-day operations is getting that going. And the important thing to know, it's just not these two guys. There's a whole team behind these two guys making your greenhouse happen. I mean, there's numerous people with numerous job responsibilities, that gets checked over by AP and Rob. And
Decades of experience.
Yeah,
decades of experience. I mean, it's amazing. We've got folks on our design team that have been doing it for 30 years.
Yeah, we have plenty of people working for us that know more than we
Way
do
more.
about specific things. Yeah,
Yeah.
I mean, it's just so there's a lot there.
But that's great and stuff. So Janine, if you don't mind, I know we got about 5 minutes left. Is there any questions that came in for these guys or any of us?
Yeah, we don't have any yet, but we'll give people a few minutes here if they want to put some in. I guess one question I had while you guys were talking, thinking about the time to design it and then put all the parts in together. So obviously that's, takes some time. If a grower has a certain deadline they want to meet, generally, and I know this changes with each project, how much time do they need to leave for just the design process?
It really depends on the terms of the contract. The more standard the offering, the quicker that we can move. Obviously, there are those factors that you have with engineering, which is specific to the structure. But if you want to move for speed, I would encourage try to go with the standard offering as possible. And we can move quickly on that. It's when we have to develop the design or we're venturing into areas that come up occasionally instead of often, that we have to spend extra time making sure that design is correct and it's going to work with all the mating parts and intricacies of the house.
Yeah, and the market and youth group will really impact that as well.
Yeah.
Whether it needs to go through building permit, you can have some building departments, and that might be a question. Jumping back to the due diligence,
Yeah.
how much time will it take you to review my greenhouse when I do submit it? Some places have planning reviews that you have to go through that they only meet on the third Wednesday of every month, and you have to have your stuff submitted at least 3 weeks before their meeting in order to get on the docket, and that could set you back by 2 or 3 months right there. Just if you had any sort of complicated building review process, but something like the one behind us here, Lordson Gardens. I mean, that's that's at least a year and a half
Yeah.
before you're going to be out on site, with a greenhouse, because there are just so many technical steps to overcome. And then, of course, a big public conservatory is going to have all kinds of building department reviews and financial approvals by the board, for the botanic gardens and all those sorts of things. So there's really no set thing, but if it's speed that you're looking for, come to the salespeople saying that this is the biggest factor to me, and our sales team would guide you to
Yeah.
a more standard offering that we can confidently, stand behind some faster timelines on.
That's good advice. I guess the other thing too is can you touch a little bit on how you work with these growers, to make sure that they can expand in the future, or that their greenhouse can, take on new technology later, when they want to.
Yeah, early on, if we know that it's your plans or future expansion, we will do everything we can to make sure that when you're ready for that, it's a fairly seamless process. It's much more difficult to go back and figure out how to make it work than it is to plan to make it work. So, as far as expansion goes, that's the key, right? If you're looking to do that, letting us know early is going to help you in the future. And as far as individual growers and shareholders go, we try to listen intently and make the best recommendations possible for what they need to do, what they're wanting to accomplish. Um, and then ultimately the decision is theirs on whether or not they wish to go forward with that or something else.
Yeah.
All right. Well, if we don't have any questions coming in, so I think we can wrap up. I'll just let everybody know we're hoping at the end of this series to maybe do a deer grower mailbag. So if you do get off of this webinar and find you have questions, feel free to email Keith or I, and we'll collect those and answer them at a later time. Thank you, AP and Rob and Keith today, and thank you everyone for joining us. We hope you found this session helpful. And just remember, if you'd like to watch any of the Deer Grower webinars, you can find those videos online, our YouTube channel, our website. And we look forward to seeing you at our next webinar on October 22nd. So make sure to register for that or watch for an email with more information. So thanks again, and have a great rest of your day.
Thank you.
Thanks, everybody. Have a good one.
Bye.
All right.
Bye.